Hello and welcome to Barkland Labs. This is the pre-lab for the energy of a tossed ball. Couple things. First off, this lab is really all about kinetic versus potential energy. Right now, this tennis ball or this volleyball don't have any kinetic or potential energy relative to this table because they're sitting on the table, so they can't fall against the table, and they're motionless, so they don't have any kinetic energy. So potential energy is if it was to fall or roll down, how much energy does it have kind of stored that it could apply? And kinetic energy is how much energy does it have when it's in motion, when it's moving. That word kinetic means something moving around. So as soon as I lift the ball, now it's got potential energy. Potentially means like what it could do. So if I drop the volleyball, it starts falling, it applies some force or does some work on this table. That's why it has potential energy when it's up here. And actually, as soon as I release it, that potential energy starts decreasing, but the amount of kinetic energy starts increasing because the velocity is getting higher as it's falling towards the table. So what we are trying to do in this lab is use a motion detector and toss the ball up in the air and measure how much energy it has kind of at all points. So those two types of energy, the kinetic and potential, we're going to see if we can calculate that at a few different points in the flight of that ball. And the kind of final theory we're testing is the conservation of energy. Remember that word conservation means being saved. So should have the same amount of energy here and here and here, and then when it's falling here, here, and here, it should have the same energy at all of those points. So what we're going to try to do is see if we can test that conservation of energy concept and see if it does hold. I'm going to show you first off the procedure, a few control variables, and then you are going to see some of the actual Logger Pro, how we're analyzing that data. So you hold the ball right about here, your partner starts collecting data and toss it up, and then you try and catch it in about the exact same spot if you can. Your collection is going to be set to about 8 seconds, so you've got plenty of time after they press play to toss it, catch it in that same spot. So once again, use both hands, don't use one hand. You're not using this to throw it at somebody you don't like. Toss it up in the air and then catch it. And your goal is to try and catch 3 different trials where you do maybe 3 different heights overall that this ball travels. Pretty simple and straightforward. Let me talk about a couple control variables. First, catch it in the same place every time, if you can. It doesn't have to be exactly perfect, but that's going to help you for your data analysis. Number 2 is the size of the ball. Now, this is kind of obvious, but I first tried this with a tennis ball, and I failed a lot. It was really hard to get the exact same height for the motion detector to track it because the tennis ball would not go directly above it. It would kind of go off the side. So the reason we're using the volleyball is it's just a larger ball. That brings me to another control variable. You want to make sure it stays over the motion detector, so as straight up and down as you can get it. There can be a little bit of variation. Obviously, that's why we're using a larger ball like a volleyball. But you want to make sure it goes straight up and down if possible and stays directly over that motion detector. And finally, you want to be careful not to let it hit that motion detector. So if you want, you can have a partner put a hand over that, like this right here. It's not, if you put it kind of right over like that, it's not going to necessarily, maybe like that. It's not going to impede the sound wave transmission, but it won't let the volleyball hit that motion detector. But hopefully you can just do a good job of catching it when it gets back down to the bottom, and you don't need to worry about putting anything there like your hand or any kind of cage that would protect that motion detector. So we're just not going to hit the motion detector. So next I'm going to go on to Logger Pro and show you how to analyze this data. Okay, so this video is to show you how to do the analysis part of and recording of your data on Logger Pro. So first off, you're going to want to open up Logger Pro. You actually want to open up the folder Logger Pro, not the application right now, and then you're going to go to Experiments, Physics with Vernier, or something similar sounding, and then you'll notice that there's an Energy of a Tossed Ball lab inside there. So you're going to open that up. That's going to set this up for you all nice for this lab. First thing you can do is you can measure the mass of your volleyball. So my mass is 250 grams, which is 0.25 kilograms. And then I also want to, actually I'm going to leave the collection time. So you're good to go now. I'm going to go ahead and try a trial. Here we go. Okay, that one looks pretty good. I'm going to try one more, see if I can get a little higher. Okay, that one looks pretty good too. So I know in the other video I said you're going to want to do multiple trials. I'm realizing it's easier if you just do one trial at a time and record your data. So what you're going to do, you go make sure you click on the graph, hit examine, click on the other one, examine. You might want to make those bigger and easier to read. 20, okay, and 20. I wish that was default larger. So as the ball is rising, you can measure what its velocity and what its height is. So notice that right at kind of the middle of the toss, 0.891 seconds, notice that it's at a height of 0.622 meters and at a velocity of 2.35 meters per second. And then so you could record those. You could record that right here. It's pretty much got a velocity of, if you round zero velocity when it's at a height of about 0.898. And then same thing, you can measure what the height and what the velocity is somewhere on the downslope here. What we're trying to show is that if you calculate the potential plus the kinetic energy at any point, it should give you about the same amount of energy because energy is conserved. And if energy is not being conserved, that means it's being lost somewhere due to friction, air resistance, something like that. One other thing you might want to note is know that 0.157, that's about the height at which I was holding the volleyball. That's something that can factor into the kind of final calculations for your problem. So that's about it. You're going to be recording those heights and those velocities, and we will be calculating the energies.